we'll take a look at, I'll talk about issues in managing large R&D projects. And for this I have chosen a real life case study. So the project case study that I have taken, this project is on machine translation for Indian languages. Our goal was to actually build a machine translation among 9 Indian languages, and this provides translation in 18 different directions. Now, what were the sources of complexity in this large project? Most importantly, this required R&D to be carried out, but at the same time a system had to be built for deployment. Now, this is not usual. You either do R&D or you do system deployment, system building, product development, but this required both. So first thing we did was we separated the language independent engines from language specific data. So we built software that is language independent of the natural language, not programming language. So we built common engines which work across languages. So when we build an engine which does, let's say, parsing, sentence analysis, it's independent of the specific languages, and it can be used for any of the languages provided the data is provided for that language. By doing so, we build a common pipeline of engines, but as you know, human languages are very distinct. They have their own idiosyncrasies. So therefore, we have to allow for variations. We always come across special cases which are there for one language, not so for the other, and we require handling those special cases. So this is absolutely crucial, to allow for variations even when we are going and building a common infrastructure. So controlling now the complexity of the system that is being built, so we have reuse. So reuse of NLP, natural language processing components. So as I mentioned, language independent software engines plus language specific data. So we reuse the software that gets written. There is reuse of linguistic architecture. So there is not just software at the linguistic level, a common analysis. And this works across languages, and of course this requires certain degree of deep understanding of human languages. It is based on Panini's analysis of human languages. Panini, as a grammarian, lived in 500 BC in India and developed the most complete grammar known today, as of today, for a human language, namely Sanskrit. Sampark is the name of the system, and this is, as I mentioned, a field deployable system, which is, by the way, deployed today and running with 5 language pairs, and another 6 to 7 are going to be released. We said we don't have manpower or the inclination to produce 2 systems, one for research and the other for deployment. So there is a single system which is a research system as well as a field deployable system. Evaluation is the most important part. So system evaluation has to be done on an ongoing, continuous basis.